Hi all, welcome to this new tutorial on the TakeOff online tool. In previous video we seen how to manage the 2D viewer and a little bit the tree view of the application. And today we're going to focus on the parameters that define a section, as we all know, relative thickness, camber and structural sections. So we've seen the left part of the tool, we've seen the viewer, and now we're going to see the data. Here in the data we have the name that we also can change here, section 3 for example. We have the T over C, and we're going to activate or deactivate this data. Let's start with the geometrical. So here we see the T over C, which is the relative thickness of the section. This is an output and an input. So if I change here, for example, let me duplicate this section. I'm going to hide this section and I'm going to put it one above the other. And now the section 3.0, I'm going to change the thickness. So for example, just 15. What it will do, it will maintain exactly the same camber line and increase the thickness. So it can be really useful to quickly assess a change of thickness due to structural requirements. Then here we have the number of control points. So imagine I want more definition. I just have to change it here. 9 control points, and what it will do, it will fit the section so we have the most similar geometry as possible to this section, changing the number of control points. So let's put the same thickness and we'll have one over the other. So now this section has 9 control points and this section has 8 control points. Also, we can change the degree of the curve, and how to be able to see that, we're going to put the curvatures and you're going to see how it evolves with the curvature. So we're going to first of all downgrade the degree. So we'll see now, of course, a degree 3 has continuity in curvatures along the span of the curves, but it's not smooth curvature. And then if we put degree 2, it doesn't has curvature continuity. And if you see, by eye, the section looks exactly the same as the blue one, but in real, you see that the curvatures are really kinky, which can give you some issues in the real life. That's why the curvature plot is really important and really helpful. Normally we used to have between degree 4 or degree 5. It ensures you to have smooth geometries of the sections. Then the same, the camber, let's again put it one over the other. We're going to hide the curvature. The camber, the camber is how far the midline between the upper and the lower curve is from the 0 y. The more camber we have, the more lift we will generate with this section. So if I put camber 5, that's an output, but also can be an input. It will modify the control point, so I have a camber of 5. Then the leading edge radius, a bit the same. It's the radius we have on the leading edge. If we change it to 1, it will increase the radius of the leading edge to 2. And we have a bigger leading edge radius. The trailing edge angle is the angle between this trailing edge line, which is the middle between the tangency of the upper and lower curve. We can increase it here also, and we'll have a more aft camber profile, or we can decrease it. So it's really nice because we can have real parameters that humanly readable, that we all understand, and the control points are automatically managed to match the requirements you request. And then this one is a very useful topic, is the trailing edge thickness. We cannot manufacture 0 thickness, so we always have a minimum thickness, maybe 0.5 millimeters, 1 millimeter, 2 millimeters, whatever. So here, in terms of proportion of the chord, we can change the trailing edge thickness, 0.5 for example, and it will change the position of the control point, so the curve remains the same maximum thickness, and just changes the trailing edge thickness of the curve. So for example, on the tip where we have really small chords, we will have really thick trailing edge thickness compared to to the chord, maybe we have something like that, and maybe on the root we have something like that. And then finally, here we have the colors. So just click on the colors and you can change the color of the section so it's more visual. Then on the results, you'll have the same colors as you have here. Okay, so we've seen all the geometrical data. Now we're gonna turn it off just to have a bit more clear space, and we're gonna turn on structural data. What does structural data means? It's the data more related to structural properties as stiffness, bending stiffness, as torsion stiffness, and the section modulus which will give you, we'll go and see one by one. So first of all, we have the area. So the area enclosed in the section. Again, you can, this is an output, but you can modify the input to put some kind of a target. I want 100, and he will modify the thickness of the section until it reaches this target value. So for example, if I put an area of 100, you will see it increase the thickness until it reaches 100. The inertia is the value that relates the stiffness of the section. So the more inertia you will have, the stiffer your foil will be. On the 3D, we have ways of understanding the inertia targeting some kind of deflection, but normally you have the value in hand. So this inertia is non-dimensionalized with the chord of 1, and it's multiplied by 1 million because the values are really small. So again, here you have a target value, maybe 100, and it will modify the thickness of your section until it reaches this value. The section modulus. The section modulus is the parameter to understand the stress you will have on your section. So the more section modulus you have, the less stress you will have for the same bending moment. Again, normally all these structural parameters goes up and down. Obviously, if the inertia grows, all the rest of the parameters grows. But there's some geometries that specifically in the optimization, you can focus more on stiffness, or you can focus more on stress, or you can focus more on torsion. So here the section modulus, and here the J, which is the torsion modulus of the section. So the stiffness to torsion. Again, here you can target a value, and it will modify the thickness until reaching this J value. So that's a bit everything. So I hope to see you on next tutorial. Hope that is useful. Please let us all the comments. If you have any doubt, please don't hesitate to tell us. See you on next video.